senior management professional with over 2 decades of experience in project planning, project management, process optimization, productivity improvement, quality assurance, lean manufacturing, digital for manufacturing and industry 4.0. He holds bachelor's degree BE in mechanical engineering from Satyabama Engineering College, master's in science MS in engineering management at BITS Pilani, Rajasthan, and a doctorate of philosophy in business management at the Hindustan College of Engineering, Chennai. He is certified project management professional from PMI USA and a patent holder. He has gained wide knowledge from maintenance, manufacturing, marketing, product development, and most passionate about process engineering, project management, and industry 4.0. Recipient of multiple awards like RAISE Awards, that is reward for industrial search for excellence, gold medalist at Improve, Malaysia, Hinduja Excellence Award for cost saving through value analysis and engineering, Chairman Award for speed to introduce BSV6 engines at and agility, totaling cost saving for the company to the tune of 165 plus crores. His excellent planning, organizing, and problem solving skills are, along with the ability to communicate and provide direction to all the levels, helped in forging relationships both with the internal and the external stakeholders, contributing to success of his endeavors. His thirst for innovation and collaboration has spearheading many projects within the company. He is very passionate to interact with the student community through seminars and symposiums on topics like use cases of industrial automation, Industry 4.0 or 5.0, IoT 4.0, quality assurance for engineers, evaluation in manufacturing technology. To name a few, he has published multiple papers on complexity, IoT 4.4, manufacturing execution systems, design and industrial training system. He has honored many college functions as chief guest, motivating students. They are patent holder and advisor on the board of studies for Hindustan Engineering College, Chennai, and Welltech Multi-Tech Dr. Rangarajan, Dr. Sakuntala Engineering College, Chennai, an industry mentor and a guide for many college students in their academics, college projects, industry, academia, connect, etc. He conducts workshops and has trained 900 plus executives in project management, lean manufacturing, process failure mode and effect analysis, total cost ownership, cost of complexity, and IoT 4.0. The list is still continuing. I am stopping with this and leaving the floor to Dr. Aravind AR and requesting the participants to listen to him. And at the end of the session, you can also note down the points, ask the questions. He is ready to answer all the queries. Thank you, sir. Dr. Aravind, now the floor is yours.
First and foremost, thank you, Mr. Nandamalan, for giving this opportunity to be part of the IAFM network, especially on your monthly review meetings. And thanks to the IAFM board members also for giving me this opportunity to present a use case on smart manufacturing technologies used in the manufacturing of commercial vehicle industry, especially. So without further delay, let me delve into the topic per se. At Ashok Leyland, we have different purpose, values, vision, and mission. Our purpose is to be leadership position, with our values being stressed on innovation, agility, trust, customer centricity, and partnership. Without focus, losing focus on creating reliable and differentiated products and solutions, having an operational vision to be agile, efficient, involving innovative technologies, being the buzzword which is there in the field. So having said this, Ashok Leyland being a 75-year-old company, many of us will be of the impression that what a 75-year-old organization have got to boast about on smart manufacturing, etc. So let us now first understand why we need to be there through a short video. Therefore, digitalization is vital, and we need to decide whether we want to drive it or whether we want to be driven by it. This was the key decision factor. So, now why is it we want to drive it? Let us understand it a little more. So, when we look at deep dive in this direction, what we observed was through various researches, both domestically and internationally, the presence and studies show us that we need to transition from being a product seller into a solution provider. So, in this journey, digitalization has a key importance. So, we had various lead indicators like global sustainable development, stringent economic norms, which are related to the environment. Economy also keeps moving forward in a different direction, unexpected. Varying customer expectation as the market matures and moves forward, and the dynamics of the changing shift in the market segmentation, competitive market scenarios in various fields, whether it is going to be MNHCV or an ICV or an LCV, all these lead indicators gives us some references in terms of being carbon neutral, development to reach global standards. With the projection of India being the third world's largest economy, how is it we are going to capture uh, the growth segment per se? And because of which customer shifts from his buying pattern and moves towards modularity. And are we going to cater such a complex customer demand through wide distribution channels? So all these things, when we are inferring, it has got an impact on both operational cost as well as affecting the bottom line, which is the gross profit. This we have got it from various researchers, including McKinsey and Company, research articles, various research articles, books, etc. So this shows that digitalization has got an inherent importance into the commercial vehicle manufacturing space. What will happen if we do not change? Change being the need of the hour, we cannot postpone the change. What happened to these companies like AMW, Kodak, Xerox, Moser Bear, Hotras, etc.? They were all once upon a time, they were ruling the earth like the huge dinosaurs, which are today extinct. Why? Because the industrial landscape keeps changing, and these large organizations found it difficult to change. So, we will become extinct if we do not adapt to the change immediately. So, what are these changes which we are now discussing about on the industrial landscape? If you look at it, Industry 1.0 came into existence in the year 1700s with the introduction of the steam engine, and therefore brought about mechanization of the entire processes. Once the mechanization of the processes started rolling in place, then the customer demand started increasing. So thereby came the necessity for mass production, which was pioneered by none other than Ford Motor Company in the year 1800s. Subsequent to that, the development of the semiconductor industry bolstered a lot of systemic changes, which led to the introduction of IT systems and robotics. Once the IT systems started falling in place, the software industry enveloped the physical hardware of the semiconductor industry and thereby making them smarter. which is the Industry 4.0 era, which we are currently in. Moving forward is the Industry 5.0 era, an era of mass customization, which is also fueled through an impact on human, society, as well as sustainability initiatives. So this is how the industrial landscape continuously keep changing. And for every change or shift in the industrial landscape, the time to change also reduces drastically. Earlier, it used to be more than a century, has now become less than a decade. So what are the changing scenarios and the need for digital initiatives? Let us pause here and dwell upon it a little bit. As we all know that people are essential for the organization. So today's the quality of people who are available are from a contractual workforce level and from rural areas where the shift has happened from highly skilled to semi-skilled to unskilled to no skilled. So this is the trend which is being observed. Similarly, on the while the trend is observed like a diminishing trend on the people front, on the practices front, there are more stringent norms which are coming in place in terms of enhanced Euro 6, Euro 7 norms, which drive the product development into a different perspective altogether, which brings in more focus on the quality perspectives of the product line. So therefore, the need arises for bringing more poka-yoke or fail-safe methods into the process as part of the process assurance systems. Once this trend is emanating, we are able to see a host of equipments and machines which are more smarter than they were earlier days. All these things have to be done at a faster pace, which demands faster workflows, agility under the agility umbrella. Now, doing all this has got an impact on the bottom line. So therefore, which is the cost, which tends towards to increase, which can be countered using digital cost solutions, lean solutions, as well as having a target for reducing the recurring cost on a year-on-year basis. So all this are needed for a digital smart manufacturing strategy. So the equation boils out like this. People, practices, equipments summated to the agility will yield in cost reduction. So this is the need for the digital initiative. Now, when we look at it a little bit further from Ashok Leyland's landscape perspective, we have put it as a circle of concern and a circle of influence. So what are the circle of influence which are there? It starts from traceability, quality assurance, workflows, planning layouts, process designs, facility development, technology adaptation, documentation, notwithstanding the training and the skill which are need to be developed. So all this gives pressure to the circle of concern, for which we need to come out with strategies to counter them. So a smarter way of planning and manufacturing is through the smart planning manufacturing technique, through which we are planned to deploy and adopt. So when we thought of this, we said we need to have a moonshot approach from the current level, because a regular Kaizen or continual improvement is not going to help us. We need to go from catapult ourselves towards the moon. So therefore, we set a set of objectives. One is benchmarking with the trendsetters, leap towards Industry 4.0, focus on talent pool development, at pace with technologies, and lead a way towards lighthouse factory. For doing all these things under the smart manufacturing approach, we need to quantum jump from the current levels, which is a need of the hour. So therefore, we need to slingshot ourselves from the current level to reach where we want to be. It is observed not all organizations, the processes are smooth always. There are problems, there are challenges everywhere, which needs to have a deeper level of penetration and a lens view. So when you start looking at it, when you look at the commercial vehicle manufacturing, we observed problems in the workforce entry and exit, because a huge amount of workforce are entering into the factory. The footfall of the factory cannot be monitored, and they exit the factory. So at any point in time, we are accountable for the workforce which are there in the factory premises. Second is the documentation lead time for retrieving them. It was very high. For every documentation, it is a standard issue which is common across all the manufacturing industries. Third is the conventional drawings and layouts, which we used to do with the help of a 2D drafter, which are manual drawings. Slowly, we migrated towards AutoCAD, which is a digital form of the drafting drawings. And still, we had issues there. Unskilled and untrained teams, if the people are not trained in the proper way, they are bound to make mistakes. These mistakes are going to be costly, leading to the bottom line erosion on a longer tenure and timeline. All these things will have effect on administrative delays, and even the workflow for any purchase order to get processed have to move from table to table. It used to take a lot of time. And quality assurance is one area where we were lagging terribly. A lot of defects were generated in the line, and we used to face a lot of issues with because of which the customer is not happy with the product which is being procured. And as with any organization, manufacturing organization especially, it leaves a lot of scrap as part of the operation. So how do we monitor the scrap flow becomes a challenge. So in a nutshell, we need to address all the above issues. How do we do that? We did a mind mapping through a technique called brainstorming, and we found out that we could outsource some of the activities. Yes, outsourcing is an option at a high cost and a dependability on the third party. Can we put a manufacturing execution system? Yes, it has also a costly option, but it has got its own complexity and maintainability issues because it is a higher end system which needs a lot of high level of skills to maintain as well as to sustain them. Then can we put extra manpower or recruit experts in the field to help out? There will be a recurring cost. However, it is a manually dependent method of doing things. It is not smart. How about exploring smart digital initiatives? Yes, it can be done through a CFT-based approach, and a high-end CFT only can take it, but it has to happen at baby steps at a time, only progressively. So these were the options which are available. So we took the smart digital initiative way after doing the brainstorming. So when we took the smart digital initiatives as a progressive step, the first thing was we need to have a CFT in place. So this CFT has to have a high level of integration with people from varied disciplines interacting with each other, co-locating themselves, as well as communicating on a more effective way. We found Ashok Leyland has got a strength towards this. The second is can only take progressive steps. We all know that Rome was not built in a day. It took years and decades together to put a proper system in place. So, however, we don't have that much of time. So, with a strong team in place and progressive steps, we decided to move forward to solutions in the digital front. So, therefore, came the focus area of manufacturing plants digitalization, which had two primary wings. One, focus on the facilities, manufacturing facilities digitalization. The second is on the office automation per se. So when we drilled further on the manufacturing facilities digitalization area, we came across digitalization of legacy machines, digitalization of new facilities, digitalization for defect detection, which is for avoiding defects reaching the end customer. Because of scraps, how to automate the scrap management. All these things needs to have a back office which runs. So when we focus on the office automation front, we found out administrative controls could be done, the workflows could be automated, the trainings can be digitalized, simulations and optimizers can be thought of. So therefore, our actions moving forward divided into manufacturing facilities related as well as office automations related. So one by one, we will go through the case studies, how we have mitigated the problem. The first one is the legacy line. So we had a power solution business engine assembly line at our Hosur Shop 5 plant. So this legacy line was available per se. So in order for it to be made running, homogeneously, we need to upgrade the legacy line. The legacy line had a concept called continuously moving conveyor, meaning the conveyor will not stop. It will keep on be moving. So when the defect is produced, the defect can be only detected at the end of the line, not in the center. But we wanted to avoid it. So therefore, in order to bring in a concept of virtual tracking, the conveyor has to start and stop intermittently. So it has to be converted into a start and stop line. So this conversion has got two options. Either we procure a new line or we upgrade the existing line. So what we went was, in order to avoid the capex, we went in for upgrading the existing line. I'm sure many of you would not understand the concept of upgradation. How is it we have done it? Any conveyor will have something known as the drive end and the driven end. So this is the drive end, where the drive is given through an electric motor for the conveyor to run throughout. So this drive end has to get changed completely. So by the looks of it, we'll all observe it is only a small area. I'll just walk you through, for the time being, I'll just walk you through the particular concept case. This is the overall length of the conveyor. See, it is around 51 meters is the total length. So when we look at it, there is a pit available on the drive end. So which is to a depth of around 2.5 meters. So the motor and the gearbox has to be replaced with the highest efficiency, which is the F class condition, to withstand the start and stops. So primarily, what is it we are trying to do? We are trying to look into the design element of the conveyor itself and try to modify it, which not many people would generally suggest. And this also requires some amount of upgradation of the control systems, controls logics, the PLCs, etc. So why is it we are doing this? When we do this, what is the advantage which we get? It is called introduction of a virtual tracking concept development, which means when the motor is upgraded with an encoder or an encoder is fixed on the motor, we'll come to know where the engine can stop before it exits a particular stage. So which means when it reaches to 90% of the stage, the hooter, which is positioned here, will raise an alarm, check if all the activities are completed. If it is not completed, the conveyor will stop. So that the balance 10%, the operator has given some cushion to complete the pending activities. So this is called the interlock option. So this is how the conveyor was upgraded for doing the start and stop activities. So you can see from the photograph here, this is the actual video. You can see how the conveyor pit, the drives were removed from the conveyor. The motors elements were replaced. They were changed. And the new fixturing was brought inside for the entire conveyor. Replaced. New motors are fixed. And the drive had to be taken dry run. So all these activities in the normal course of run will have taken 15 days, but we had done it in 1.5 days. With a lot of preparatory activities, we were able to accomplish it. This is the end effect, the completion of the conveyor and movement of the engine. So when we look at it, we have 15 stages of the conveyor being partitioned virtually. So each of the stage has got a lot of tools which are required for completing the operations. For example, this is an engine assembly conveyor. So we need to tighten all the bolts. So what we are seeing here in the form of purple are the tools or the Wi-Fi torque wrenches which are used. We also have other equipments like coolant filling and oil filling equipments which are marked in yellow color. Some of the stages have got more than 20 tools. So at this stage, the operator has to use all these tools in a sequence, complete the activity, and then allow the engine to pass. So this is just to give you the magnitude of the problem, which was earlier faced before the conversion. Now, with the introduction of the Poka-yoke tools, only when the operation is getting completed, we get a green signal through the PLC for indexing. Otherwise, it will not index. We'll get a hooter to say that there is a fault. So this is how the encoder was fitted and how the stages are monitored and what is the outcome which is observed. So this was done within a record time of 3 working days on a weekend, 1.5 days for changing the drive, 1.5 days for configuring the system. An example of the tools which are used, we use Wi-Fi torque wrenches, which you can see it in the figure. These tools communicate over Wi-Fi technology. We have receivers on the line side where the count of the operations, if for example, the cylinder head has got, one cylinder has got 4 bolts. So each cylinder has to be tightened with 4 bolts, which means there are 4 cylinders of operation, means totally 16 bolts have to be tightened. So this count checker will display how many counts the bolts have been tightened to. For example, 20 Newton meter is the per bolt tightening torque. So this Wi-Fi torque wrench, when it reaches 20 Newton meter, it will give a click sound. So the click is monitored through a Wi-Fi micro switch, which transmits the signal and the count checker captures it as one count. Like this, 20 counts, 16 counts has to be reached, after which this gives a green signal to the PLC for moving ahead. While this is the earlier concept, we observed multiple count checkers are there in the line, which used to create a confusion and a problem. So while upgrading, we have introduced the concept of single count checker where multiple Wi-Fi torque wrenches are in integration with the count checkers. So this reduced the number of count checker points also in the line, and it resulted in power savings as well. So this is one case. Now moving on, this is the first time innovation done in Ashok Leyland, that too in the engine assembly line, where all the critical to quality parameters were interlocked, poke-out, handshaked, thereby resulting in virtual tracking of the conveyor system. It was done in a very, very frugal methodology. The next one is the new era, digitalization in our P15 engine assembly module, where the concept of the engine assembly layout itself was cleared using virtual reality module. So wherein HERA was reduced to 71%. Similarly, for the operator, we are given operator guidance, process monitoring, data acquisition and control through a tool called the Odin. The Odin Manager is a completely digitalized software which interacts not only with the line level PLC controls, but also with the drawing level PLM, accessing the drawings, and it shows the drawings at the right stage for the operator and gives the operator instructions, visual instructions, what is to be done. So this was brought in as a first stage. Then all these workstations, which are 42 in number, were connected workstations with more than 480 intelligent sensors, bringing a cumulative 6 million data points per year for preventive maintenance analysis. The other salient features of this included bringing in 12 in-process verification machines, unmanned stations, 12 numbers, 24 numbers of dispensing stations, and 100% pick-to-light in kitting area. So all this helped us in making the assembly card as digital. So therefore, we have digitally enabled and made the engine line ready for future. Few of the challenges which are converted into opportunities are, we had a challenge of moving the finished engine from the end of line to the engine testing area. So that was mitigated by providing AMRs, which is automated mobile robo, which can navigate through a constrained workspace. Similarly, each engine has got multiple parts which are getting assembled. So these parts need to be checked at the end of engine assembly line in order to eliminate customer side defects. So we had gone for a robotic vision-based inspection, which is the end of line inspection, which can be seen on the right side, which takes photographs of the entire engine, compares nearly 32 characteristics within a short span of 3 minutes, and clears the engine for delivery. So this is the first time in Ashok Leyland where we have used an AMR and robotic vision inspection for quality automation. All this you will find that needs skills to be enhanced. So how do we do that? So we were able to enhance the skill through our Gurukul, which is the Nalanda Learning Center, which is exclusively designed and developed for eliminating the skill gap. Why this skill gap is there, or why Nalanda is required when we look at it introspected? The observation is that 9% of the associates would be retiring in a year. So therefore, we need to onboard quickly skilled workforce, or onboard the workforce and skill them quickly. This can only be mitigated through a digital product and systems increasing inside Ashok Leyland workspace, like digital inspection systems, Pokayoke systems, all these things. So what we did was we evaluated various types of training modules which are available and what can be the deployment of these training modules. So one is classroom training, which is traditional, VR training, which is virtual reality based, which is contemporary, safety, learn with fun, as well as having retaining a knowledge bank. So the digitalization initiatives added in the Nalanda Center are, apart from the regular industry modules, which are, first one is the virtual reality module, giving exclusive training on fire safety as well as work at height, which is part of the safety. And additionally, the process related trainings are given on kiosk based modules where the operator can stand in front of it and using a touch screen, the entire training module is delivered. And it doesn't stop there. The operator is evaluated for his performance and is given a certification. This certification is cross-referenced across the various Nalanda learning centers which are there, and an MIS is populated. Now, all these things are construed 100% indigenously, which is a homemade design. So far, 3,500 plus contract executives have been trained under the flexi manpower regime. So the new recruits are trained and ready for deployment. Then comes the scrap management. As with any operations, scrap gets produced. So we need to manage this scrap. So how do we manage this scrap? You can see it in the video. When the scrap management vehicle comes for taking the scrap, at the gate end, automatically the number gets captured using an ANPR, or the automatic number plate capturing camera, which recognizes the number plate and then permits the vehicle through the weighbridge where the tire weight is taken. While taking the tire weight, the driver has to come out. So for that, we are given a driver detection camera. And then it goes to the scrap area where the scraps are loaded, photographs are taken, comes back to the main weighbridge where the scrap weight is taken and directly interfaced with SAP. There is no manual entry per se. At the exit gate also, the vehicle is checked for all the faces and the weights before it is exited from the organization. So therefore, complete transparency is available. Tracking is enabled in all stages. Weighbridge is manless, so therefore manpower is optimized. All the documents are now digitally moved, leaving behind a digital forensics in the form of photographs, so that later, whenever there is an audit, they can always check it online as to the efficacy of the system. So all in all, the savings resulted to close to around 64 lakhs recurring per annum. So the end-to-end system was developed, designed and developed by Ashok Leyland indigenously. Next comes the M-Alert system, which is short form for machine alert, related to maintenance function. Whenever maintenance happens, currently the operator or the executive has to go into the SAP system, log inside and book the maintenance, which cost a delay, and someone has to go and close it in the SAP manually. So we thought, why with the advent of mobile phones, why not we exploit the technology? So we created an app indigenously. So what this app does is, you can scan the QR code on the machine, the asset number gets captured automatically, and whatever is the problem has to be entered manually on the keypad. In addition, the photograph of the problem is captured and posted as a breakdown. Once the breakdown is posted, it goes into the maintenance function as an alert. and a resource is allocated for resolving the breakdown. It is time stamped. Once the time is getting stamped, the time taken to resolve is used for computing the mean time to resolve, MTTR. And once it is resolved, the photograph of the resolution is also taken and it is uploaded. So the entire cycle is captured and brought in digitally. This gets extended with preventive maintenance, asset management tracking, and a host of other related modules which are under development. So all this helps in bringing about convenience from breakdown calls and solutions through mobile phone. Digitalized machine manuals are now available. You can track it on the move. You can have the MIS on your phone, on the palm, and it is fully scalable. More than 10,000 plus equipments are now brought under the system across the 9 plants of Ashok Leyland, which leads to savings of around 2.4 crores across all the plants. So it's an end-to-end breakdown management plan, which is developed and deployed today by AL. And it's a homegrown solution. The next one is the Pokayoke solution for vision-based Pokayoke, which is for defect capturing, completely developed by AL engineers in Python language. So the program was developed within 20 hours, and we have deployed it in multiple systems. So with the aim of horizontally deploying it to more than 100 vision systems before March. That is the target. So you can see one of the case which is being run continuously, which is the oil cooler, where we need to ensure all the items, gaskets are present before it gets assembled. So this is one of the prime defect area where it is now ensured to run defect free. Then comes the digital walkthroughs through simulations. As I said earlier, we used to design layouts in drafting using manual sketch, and subsequently what we migrated to AutoCAD, which is a digital platform. But the best is to be done on a 3D based platform. Now imagine if we are to convert all the machine shops available into 3D, we need hell lot of resources to complete this activity. However, we were able to do this with support of college students from various colleges. More than 40 students participated in this initiative for about a time period of 6 months, 6 to 8 months. And we were able to bring 4 plants totaling 600 acres into a 3D environment within a short span of 6 to 8 months. This has been done, and you are able to see the fruit of the pudding. This is the first time in Ashok Leyland. Enabling this has given us a 3D visualization perspective. It has improved the mock-up and the planning activities. Since the walkthroughs are available, it is convenient to operate or to plan sitting in the office rather than placing ourselves in the shop floor environment, thereby reducing the cost associated with travel, etc. Efficiency improvements through Power App, leveraging the maximum potential available through the facilities which are already available with us. Microsoft has given us Power App and Power Automate as digitalization tools. So using these tools, we have ourselves developed multiple applications by undergoing training through a program called App in a Day, which can be seen in the bottom left corner, which Microsoft is offering through their channel partners. One day is all it takes for us to learn this application and develop the various applications. You can see one is for the Gigant tool procurement application. Then we have the capacity planning application. Then we have the commitment approval application. Then the budgeting application. All these things resulting in multiple minutes of savings in terms of hundreds of minutes. Earlier, it used to be around 730 minutes. Now it has got reduced to 300 minutes, about approximately 430 minutes have been saved because of this applications. Similarly, leveraging the SAP process, we were able to introduce something known as a project test, which is for budget project approvals in a workflow-based methodology, wherein we create the request at the planning stage and it moves to the completion over SAP platform in a workflow-based pattern from laptop to laptop instead of paper to paper. So this has helped in bringing in transparency as well as reducing the lead time for movement. The next comes the development of leveraging the existing resources like Excel. which is used to create optimizers. Earlier, for energy optimization, what we used to do is we used to manually calculate with the permutation and combination methodology and iterate to technique as to which energy source should we use, whether wind energy, solar energy, because lots of constraints are there. Wind is not available 24/7 across all the seasons of the year. Solar is not available in the night time. Power purchase is a costly affair. When do we deploy power purchase? When to use the generator? How much to use the generator? All these things were the variables which are there. So which we put it in the form of a digital energy forecaster, which was developed using Excel macros. Similarly, for the punching machine, the program generation was done using macros, and the entire program for a FSM, which is a frame side member punching, CNC punching machine was developed, designed, and once we key in the parameters, we get the programs which can be copied and pasted into the machine controller. So this has given us a savings of around 2.4 lakhs per annum. Several such multiple Excel-based applications, we are developing it in-house itself and using it for our own benefits, part of the robotic process automation processes. Similarly, because you can see the lot of workforce which needs to enter into the factory on a daily basis, and we need to maintain track of them also. Footfall entry into the factory is a primary importance when it comes to inspector of factories. So earlier it used to be done on a manual basis where entry and exit used to be monitored using a manual record for visitors as well as for other third-party contractors. Even though we had biometrics, which became a problem during Corona because transmission of diseases and all used to happen. And some of the cases, biometrics never used to work because of the aging factor of the individuals. As we grow older, the fingerprint recognition becomes difficult. So therefore, what we did is we went in for a face reader and a turnstile-based access system for the organization across all the 9 plants. So we were able to get a contactless access control with an automated entry and exit. Only the authorized persons can come inside. Without unauthorized persons cannot come inside. So this has further enhanced the security component of the factory itself. Similarly, at any point in time, we can come to know how many people are there within the factory because it is a real-time data is getting tracked, and we are able to maintain the management information system at any point in time with the statistics in place. So all this you will find, you may think that it takes a lot of time. No, it doesn't take a lot of time. It hardly takes about less than 10 seconds for a person to enter and exit. And also it checks for unauthorized areas, people entries and restricts them at the gate level itself. So this system is deployed across all the plants within a span of a year. So our projects, whatever we are handling, whether it is administrative automation, workflow automation, digitalization, training and development, simulations, it cuts through all the verticals. So we need to act through the digital smart planning for manufacturing. As a horizontal deployment, we wanted to deploy them to the Uttar Pradesh, UP, Lucknow plant, which is coming up. And whatever we have designed are all scalable, which means future plants, when they come up, we can deploy these solutions there. And they are all sustainable because we have developed it in-house. The development resource is also available in-house. We will be able to sustain them on a long term. As a mitigation plan, we have a plan in place where we get support from specialists and consultants and continue the existing method. So whatever digital ideas we have sowed today shall start reaping the fruits in the years to come, starting from the next financial year onwards. So the challenges faced by this digitalization journey, as with any migration project related challenges, there are many. It all starts with first, I will not do it, which is the employee reluctance. Then once they start understanding the nuances, the learning curve kicks in. So as they go into the learning curve, they'll find that there is a skill gap, which means they have to upskill themselves, and which leaves us with the obsolescence which needs to be handled. Some of the machines and systems, controllers are all quite obsolete. So how do we tackle these obsolescence? Through the skill gap, is it possible to mitigate the obsolescence? Can we bring in lean, low-cost initiatives? Are all the some of the challenges which we faced. Then comes the competitive peer pressure. Among the peers itself, people will not agree for any new system which is coming inside their portfolio. There is always a threat to the threat which they feel. Once they start getting realizing the benefits, they started onboarding And they started advocating for these systems on the long term. So therefore, the question of longevity gets mitigated. And even though the ecosystem is young and it is fresh, it is an amateur ecosystem. So how do we handle it? The moment people started getting upskilled, slowly, progressively, Kaizen way, one step at a time, they were able to absorb everything and we were able to mature. So therefore, even though the journey was not an easy cakewalk, but the destination was clear for all of us. And today we are reaping the benefits of it. The feedbacks from our senior management were quite encouraging. We have feedback from our managing director, feedback from our president and COO, similarly, feedbacks from lead user management, key management professionals, and all, who have all summarizingly said that we need to act only through smart manufacturing planning. So, automation, digitalization is the way forward. This cannot be done by a single person. So I will not like to take the credit for this. This has been done by a CFT, for a part of which I was a member of the CFT. So the total length and breadth of the CFT, it extended up to 100 people. So what you're seeing here are only the key members who have driven all these initiatives. So what are the results? The results are very simply put, 12 crores saved. It's not a small amount, it's a huge amount which goes into the profit of the organization through various initiatives. But it doesn't stop there because we have some recurring savings also, which year on year gets accumulated and we stand to reap the benefit moving forward on a sustained basis. Transformation of people and engagement is not simple because when we look at it, people normally tend to do some routine work, which is the routine daily management. So when we started breaking down this routine daily management, and if we start automating them, that is making some of the man-dependent operations into man-independent operations, we observe the time available for a man gets freed up for putting more thoughts into innovation, having more planning time available, and he's able to impart more trainings like how I'm able to give you today. So therefore, man is to create, while machines are for routine. So daily routine management and administrative management reduces drastically, helps in increasing helps innovations to increase because of the free time available for the man to think and act upon. What was the timeline for all these projects? All this happened within a span of a year. At multiple times, multiple timelines, start points, multiple teams started working in tandem, and we were able to complete all these projects as per the target of the organization. And they were all, validated by our finance, and it has been recognized in various forums. Now, all this we get competed and we got many multiple awards, and a few of the work which we have done, we were able to convert it into a research paper and get them published also in certain research magazines, which you can see it here on the scientific magazines, and there is a certification which you have received for that as well. While we do all these things, we are moving towards a new a lighthouse factory concept, which is one step before the dark factory, which is now emanating across the globe, wherein we'll be doing human beings a justice by reducing all the non-value-added mundane activities and making use of the human beings' creative efforts for only value-added activities. By automating, it is not going to cost us jobs. It is only going to enhance our efficiencies, enhance our value, and give rise to more automation jobs, high-skilled jobs moving forward. Having touched upon skill, we need to upskill ourselves because of the shift in the industrial landscape. So what we did was we made a footprint. So for industry 5.0 where we are, so when you look at, we'll go level by level. So when you address it on the level 0, which is the sensors, actuators, which is back to basics, what are the skill requirements? We are able to compile them, consolidate them. Level 1 is for PLC, level 2 is for SCADA, which is supervisory control data acquisition. Level 3 is for manufacturing execution system, of which smart manufacturing is part of. Then comes level 4, which is artificial intelligence, and level 5, which is your industry 5.0, which is human centric, which is a symbiotic relationship between man, machine, and environment. So for all this, we have mapped the skill requirements, which is the first time in the industry, and accordingly, the trainings are being populated. So people used to ask me, how long do you think you need to acquire a new skill? You need 1 year, 2 years, 10 years? Well, the reply is here. If you are able to scan the QR code, you can scan it and find the answer. So what are the basic skills which are needed? I always used to give this slide to everyone. You need to have an out-of-box thinking concept. Mind mapping is one tool which we have used. You have also experienced it. And the cost engineering is one thing which was demonstrated through this case study. How to use small-time electronic components in a wider space. Science is the fundamental for all this. Critical thinking skills are needed. We need to have a disruptive thinking process itself if you want to learn and grow. Last but not the least, the I can't do it mindset has to be knocked off. Finally, please do publish a research paper which can be very well done, not by if we feel that our age is very high, we'll not be able to do it. Let us involve academics. Academic students are always there. Let us take their support. Let us encourage them. They're also willing to come forward and be party to the projects. So you can see the number of papers which are published and the number of patents which have been applied and pending. So this is all part of the societal academic initiatives which I have taken, and all these students are mentored and guided by me. So therefore, a small step for digital initiatives, a giant leap for future of Ashok Leyland Smart Manufacturing Factory. Thank you, ladies and gentlemen, for listening to me across this journey. And if there are any questions, I can take it now.
Yeah, thank you, Dr. Aravind, for your nice lecture. It was quite interesting, and everybody got enlightened by your speech. Any other question is there? Somebody can raise the hand so that we can connect you. Any questions? Sir, any questions, please? No, I don't think nobody is ready to face Dr. Aravind, because you are highly knowledgeable. We are being enlightened by you, so they don't want to ask the questions. We will take it in a positive way and proceed further. Doctor, we are highly grateful to you and thankful to you for your august presence to present about smart manufacturing in automobile industry. Thank you very much. Dear Benagappa sir, would you like to ask any questions?
Sir, no questions, but session was very informative, sir. Thanks for organizing such a beautiful program. I think we can utilize sir specialty furthermore. That is what I am thinking.
Yeah,
very knowledgeable. Sir, and whatever presentation is all practical, sir. Yeah. Thank you, sir. Thanks for nice presentation. And Leyland, sir, thanks for organizing a fantastic program.
No. What I am telling, if you want, I will ask Dr. Aravind to visit Shimoga and enlighten you through for the IAF beneficiaries. We can do that also.
See, if that is so, I want him to address on Industry 4.0, sir.
Okay. Doctor, if possible, try to help them. Suppose if you are moving that side, try to, you please communicate me. I will contact them and then we will make a lecture program there also. Yes, these people are highly interested people, sir. Shimoga people are nowadays getting what you call brighter, but day by day they are getting brighter. So you can enlighten further them also.
So definitely we utilize your service, sir. Thank you. Thanks, Dalan, sir, organizing for a wonderful program.
Thank you. Doctor, you want to say something?
Thank you, sir. That is all from my end. If anything is there, please reach out.
Thank you. Thank you so much, sir. Thank you.
Dr. Aravind, very much, we are very much grateful to you, because when we asked you, you without any hesitation, you accepted our invitation. Thanks a lot. And we will do so many songs. Sir, in the YouTube, sir? No problem.
Yes, sir. Please go ahead, sir.
Can we display your program in the YouTube?
Please go ahead, sir.
Okay. Thank you very much.